Hello my dear students, once again welcome to your online class. Today we will be learning the third chapter of your physics textbook, that is the machines. Okay, so in your junior classes we had a very simple definition of machine. Okay, so what was that? That was anything that makes our work easier is said to be a machine. Yes, that's very true, that everything that makes our work easier is said to be machine. Generally, we have a concept that the machines, they usually resembles a big machineries like the JCBs, the bulldozers, the tanks, okay, and complicated pulley system. We assume that they are machines, but it's not like that. Anything that makes our work easier, it means that even a simple stick can be a machine, like or a simple iron bar, okay, using which we can easily pull off the nails from the wood, or a hammer using which we can easily nail pins into the wall is said to be a machine. So machine is generally a very simple thing. Okay, it can be even a very simple thing that makes our work easier is a machine. Like example, a nut cracker, a knife, okay, the axes, the pulleys, all of them, they are a machine. So basically this chapter will learn that there are 4 functions of the machine. So if anything that fulfills any one of these functions, then we can call that object is a machine. So what is it? So the first function of the machine is to multiply the force, that is the force multiplier. So the machine is anything that can multiply the force. For example, the spanners or the wrenches or even the pliers also, the nuts that which we cannot open with our hands, we can easily open with a spanner. Okay, so those are the force multiplier. The second one is change in the point of application of force. So using machine, what can we do? We can change the point of application of force to the convenient point. For example, imagine a bicycle. Okay, so if in a bicycle, suppose we have a bicycle, 2 wheels, and then we have a seat somewhere here. Okay, we have a handle. And then where do we pedal? Where do we apply the force? We apply the force in the convenient point. It's very easy to pedal a force here. So imagine that we did not have this system. We did not have a machine. And we had to pedal at the back of the wheel. So how would it be? It would have been very difficult pedaling backwards. Okay, so using machine, we apply a force at A and this force is carried to the point B. Okay, so the machine, what can it do? It can change the point of application of force to the convenient point. The third one is using machine, we can also change the direction of force. The example is a simple pulley system, like while pulling a water from a well. Okay, so when we pull a water from a well, every one of must have seen a well at least in a TV. So from a well there is a pocket deep inside. Okay, so tied with a rope. So if there was no pulley, you had to pull it upward. In that you have to apply a lot of force. There will be a lot of pain in your hand. But if I use a pulley here, okay, a small pulley, and then I pull the rope downward, then what can I do? I can simply catch and pull it down. So in that case, we can use our weight as the force. Okay, so using a pulley, we can also change the direction of the force. And the last one is the speed gainer. You must be very familiar with the cycle nowadays, which has a gear system in it. So when we pedal slowly, our cycle moves faster. So using the machine, we can also obtain the gain in speed. So those machines are said to be the speed gainer. So the 4 functions of machines are the force multiplier, the change in the point of application of force, the change in the direction of the force, and finally the speed gainer. So now we learn some of the technical terms that is related to the machine. So here we will be learning about a very simple machine. So that's why these machines are called to be a simple machine. So the 7 technical terms that are related to the simple machine is load, effort, the mechanical advantage, the velocity ratio, the work input, work output, and finally the efficiency. So the first, coming to the load. What is the load? The load is the resistive force that is to be overcome using a machine. For example, if you had to lift a heavy stone, okay, so if I had a very heavy stone laying on the ground, okay, which you cannot lift it simply with the hand, so what can I do? I can use a simple iron bar. Okay, so I can use a huge iron bar, okay, a long iron bar and a small stone here. Okay, so if I push it downward, so this stone will roll over. Okay, so here what is the load now? Here the load is the stone. So this is the resistive force. By applying a force, I have to roll on this stone. So the resistive force that is to be overcome using a machine is said to be a load. And what is effort? The effort is the force we are applying to overcome the load. Here what do? I push it downward. So that is the effort. There is the load. Load means the resistive force. The stone needs to go that side. That is the load. And I am applying a force to push that stone. That is the effort. So clear? Load is the resistive force to be overcome using a machine. And the effort is the force we are applying on the machine to overcome the load. Now the third term is the mechanical advantage. So what is mechanical advantage? It is simply defined as the ratio of load to the effort. Okay, so load divided by effort is said to be the mechanical advantage. Now another we have is the velocity ratio. Okay, so to understand this, we will take a simple example of a seesaw. Or like if I have a seesaw, okay, and here I have a fulcrum. So the seesaw, which is not, both the arms are of not equal length. So suppose here I have a load. Okay, there is a stone. I am applying an effort here, E. Okay, so now when I push it downward, okay, so if this is the surface of the ground, so when I push it downward, that is known as the dE. That is the distance travelled by the effort. So in the meantime, when this point reaches to the ground surface, so where will this reach? This will reach to a certain height there. So it goes there. Okay, so now the load has gone there. So this displacement is known as the dL. Okay, so effort distance is the distance travelled by the effort, and corresponding to which the load also travels a certain distance, and that is said to be the distance travelled by load is said to be the load distance, or the load dL simply can be represented by dL. So what is the velocity ratio? The velocity ratio is the ratio of the distance travelled by effort to the distance travelled by the load. Simply it is dE divided by dL. Okay? So dE divided by dL is the, what is it? It is the velocity ratio. So the velocity ratio is the ratio of the distance travelled by effort to the distance travelled by the load. Okay, then we have the work input and the work output. So what is the work input? The work input is the work that we are doing on a machine is the work input, and the work output is the work that the machine does is the work output. For example, you may take a hand pump. Okay, so what is the work input? I pump its handle. That is the work input, the work I am doing on a machine. So the result of which, what does the hand pump do? The hand pump pulls the water out of the well. Okay, so that is the work output. And finally we have the efficiency. So this is the efficiency. So what is the efficiency now? The efficiency is the ratio of the work output to the work input. Okay, so the definition of efficiency is the ratio of the work output to the work input. So these are the 7 terms, okay, very important from the examination point of view as well. So now coming to the another topic, that is the principle of machine, which states that the work input is always equal to the work output. A very simple definition states the principle of machine. So the principle of machine states that the work input will always be equal to the work output. So using this principle, we can find the relationship between the mechanical advantage, the velocity ratio, and the efficiency. Okay, so using the principle of machine. So now using the principle of machine, we can easily find the relationship between the mechanical advantage, the velocity ratio, and the efficiency, for which you need a concept of the work done from the previous chapter as well. Okay, so the previous chapter we learned that the work input will simply input means the effort you are applying. So it is E into D of E. Okay, so the effort into the distance traveled by the effort, and the work output will be equals to the load into the displacement of load. Now since I have the efficiency is equals to the ratio of work output divided by the work input. So I can do this one as work output is equals to L into DL divided by the work input is E into DE. Okay, so now what can I do? I can separate it L divided by E into DL divided by DE. Okay, so now to bring this one in the form of the velocity ratio DE divided by DL, what will I do? I will do simply this L divided by E into, what can I do this one? This I will write 1 divided by DL divided by DE. Okay, so finally substituting the value of mechanical advantage as load by effort and the velocity ratio as the DL divided by DE. Oh sorry, this should have been, since I am making a reciprocal, so it is D of E, D of E divided by D of L. Okay, so finally what can I do? I can write this one as efficiency is equals to load by effort. What is load? The load by effort, from the definition of mechanical advantage, it is M into MA into, now what is DE by DL? From there I see that it is the velocity ratio 1 divided by D of VR. So therefore hence I get the relation efficiency is also the ratio of the mechanical advantage divided by the velocity ratio. Okay, so this is how we can find the relationship between the efficiency, the mechanical advantage and the velocity ratio.